Oh, hey, I was totally doing work here. Yeah, work on it. Nope, actually, I was. So, let's see, will this work with me?
Aha!
Yeah! So, I have a Steam Deck now, and for giggles here, it's running KiCad, and we can actually zoom in and take a look at stuff on here. Echo? Why? Oh, the deck. There we go. Yeah, this was picking it up. But how is this thing for cool? So we can like come in here and see stuff, and you know, on that, because that's pretty cool. But yeah, we're not actually gonna use this today. But you know, kind of fun. So go ahead and hide that for now. But yeah, no mic on it works. Yeah, no, it works pretty well. So yeah, what the deck is really meant to be used for. Yeah, so I'm having some fun with that. Go ahead and put it away for now. So today is the last day of the CM-153. The 512 gig version. This is a 1 terabyte version now. I got the 64 gig model and yoinked that before I even booted it and just imaged it over to a 1 terabyte drive. So yeah, because all the options were terrible. So yes, but today is the final stream of the CM-153 card design process. By the end of the day today, I'm going to have sent an email to the person who sent me the original images and asked them to confirm a few things. So I am really excited here because it's almost over. So yeah, it's been way too many streams and taken way too long. But as of right now, I think the circuit board is electrically complete. Whether or not it's accurate is another question that we really can't answer. And I say we because I've been getting some help from both Helen Croft and Manjenko Tech here in chat, and I'm really appreciative of them both. So yes, but that is about it. So I'm gonna head over to there now and give you a walkthrough of all the changes that have happened and show you where I'm at in the project, because it's finally pretty much done, but we do have a few objectives left. I'm just taking this so I can make sure it's like actually off, because I don't want it roasting itself in there. So, oh, dog face. Aha. And check this out. turn it on. You'll get a kick out of this. They just got their Steam Deck as well. Look at this. Real-time remote capture on it. Completely wireless. NDI. That's how I'm doing that. So, yeah, actually, let me shut this off as we go over to the other desk, which, you know what? I should just push the button here so it'll actually go over there. Oh, wait, no, I need to press this one, and then this one, and then this one. Aha! Okay, there we go. Hello, everyone. Oh, the camera fell down. Let me fix that. There we go, I bet. Yeah, that looks about right. Whoa, Lanesy, thank you for the 5 gifted subs. You're gonna try and daily drive your Steam Deck with your dock? Good luck. I'm not even gonna pretend I'm gonna do that. Wow, thank you, Lanesy. What is it? Oh yeah, this is September, so you can get up to 30% off of subs if you subscribe up to 6 months in advance. So if you want to save a little bit of money on subs, you can do that. So there you go. It's the September notice and explanation of what that actually is. I am going to shut this down now. Also, fun fact, I'm using the GitHub desktop program to do Git stuff on here because I mean, you can type on this actually, and it's actually, there's a lot that I could talk about with this thing, but I'm not going to get into that because that's not what today is about. Anyway, the GitHub desktop does not work on here, partially because of how Steam has set up the Arch environment on here. It's really annoying. So yeah, if you really think you're going to use this as like a Linux desktop, you're probably going to want to install a real operating system, not the Steam Deck one, because it is severely gimped. So yeah, but there we go. So Seiji, thank you for the sub, the Prime sub, and for 2 months. Commander Keen, thank you for 5 gifted subs. Wow. All right, let me walk you through what we have going on here. Since when was setting up a new iPhone such a pain? That's oh, the Steam Deck, is that you're calling it? Is KaiCad on the Steam store? It is in Discover, the package installation. You know, I can just show you on here because I mean I'm using basically the same thing. It's just KDE's application installer thing. It's just stuff that is installed through here gets installed in a different way on the Steam Deck. Normal software. Dogface, my apologies. I didn't run the program that makes the Deck Talk stuff work. One moment. And that's now up and running.
Cheer 100,000, 100 another, 3 another. End of line.
All right, there we go. Now it's working. And Gemand just got a really interesting thing in there, I think. Yeah, okay, that's... Yeah, we'll cover that. Anyway, to finish answering your question, Helen Croft, KaiCad is in here. You can just install it straight from there. That's weird, it shows it there. Yeah, install from Flatpak. So these are the things. If you install Flatpaks on the Steam Deck, they stay. But the normal way that Steam Deck updates the operating system, as far as I'm aware, is that it just downloads a whole disk image and then just rewrites everything. So it's kind of weird. So I expect like KaiCad, no, not KaiCad, but some stuff to disappear. So yeah. But all right, Spy Robot, thank you for the tier 1 sub. And yeah, thank you for the tier 1 sub for 6 months. I'm just trying to read that. Sorry, brain fart. All right, and Spy Robot, thank you for the 90 bits. See, you only know of IKEA flat packs, yeah. All right, so J-Man banned the Python calculator. We're gonna have to do math this time. And that means I'm gonna have to use a calculator, so we're gonna use the HP 41CX today. That will be a little badge there. That's gonna be the calculator for today, but I might forget, so we will see what happens, because it's actually quite the possibility. Yeah. So anyway, hey look, it's a card. Let me get KiCad open here, because, well, first off, here's the GitHub repo. If anyone wants to look over this, I will highly endorse it, because today's the last day to look at this stuff. So on the GitHub repo, I have an issue that I've opened, and in it we have
CHER100 love your streams.
Thank you. Thank you for the 100 bits, Spooky YNL. Wait, why do I say Spooky YNL? It's Spooky NL. Thank you. Okay, so in this GitHub issue, I have 7 bullet points plus some bonus ones down here. And other than the second one, which I actually was able to do this morning, all of these still need to be fully finished and verified. So each one of these is an objective that I want to get done today, and I think they can all be done. So that's the goal. So let me bring this over here and open up the card so I can show you guys what's going on, because it's done. That's the thing. This was my goal, to have the card done by this stream, but every trace is routed, all of the test points are on, every connector, every chip. David, I started it a little early just because I wanted to get, I didn't have anything else to do here. I was just going to sit around doing nothing for an hour, so yeah. But everything's done, other than the minor things over here. So the plan is, as I mentioned earlier, we're going to tighten up all the little things that are left. And like some of these are going to be things like the silk screen for the chips is kind of ugly. It doesn't match what everything else looks like here. So that's part of what today's objectives are going to be. And then we're going to double check some things. Probably going to end up changing the pads on the ISA connector to look more like the ones on the original card. Just little things like that. But at the end of the day, I'm going to be sending this off to Roland, who's the one who gave me the original pictures, and I'm going to have them check at least 2 traces on the UART, because there's 2 things that we really don't have a 100% assuredness on here. So one of them is this trace, and this goes from, I actually understand how this card kind of works now, which is like maddening, because I didn't want to know how the card works. Did you have V scoring to the edge connector? So Paul Guy, there isn't, as far as I'm aware, there's not a way to do that in like the Gerbers or whatever that you send off. However, if I go to File, Board Setup, and then where is it? There's something around here. Yeah, here we go. This is probably going to do weird things with all that. Yeah, I don't think it liked doing that with NDI and OBS. But anyway, this shows card edge connectors, yes, beveled. That's how I have it set. So the thing is it doesn't do anything. Hopefully now that this is no longer zoomed, it's going to behave normally. No, something's really wonky. Let me see if I can fix that. I don't know what's going on. It's not happy. I have an idea. I might just need to run Ethernet and then have it reconnect. So let me try that. All right, Ethernet. Have it pop up. Okay. All right, and then I'm just gonna turn off Wi-Fi. Okay, OBS NDI is gonna cry over there. Probably. Let me go enable and disable and re-enable that. See, oh, it has a specific option. Yeah, but the thing is it doesn't do anything. Let me get this back, and then I'll show you what I mean. Actually, let me close that dialogue. That'll be a good, like, distinctive. Oh, it's done. It's reconnected. Okay. Hide. Show. Okay, I didn't do it. There. Okay. Ooh, that's interesting. That's working. All right. Oh, laptop. And there we are. Okay. that was different. Alrighty. You know, I didn't check that the phone's actually working. It is. It's good. Okay. So, let's bring up the card view. All right. So here's the card. All right. Down here we have the edge connector, but it's very much not beveled in the 3D model, which is annoying. And then it's gold plated, except it.
Starhawk says CHEER 100. Oh my God, it's full of stars. End of line.
That's a good reference for that one. So we can see that it's gold plated there, and then the pads for the chips are gold plated, but then the test points I made are not gold plated. I don't know why. You know what? Oh, I made those as pads. Okay, I was gonna say I'm not 100% sure those are gonna have solder mask relief, but I made them as pads, so that's kind of inherent. That's pad 2, so that's good. Yeah, everything is pads. So you removed the not used ISA pad the original card has. Actually, it was not on the ISA card that we started with, the Monster FTC, so I'm gonna have to put it in there, is what it's gonna be. I will be adding that. That's gonna be one of the things. The other thing is that these pads need to be rectangularified. You gotta remove the rounded corners. And then the original card here as well, there's a couple of things I wanna edit about the pads there, the fingers. It has, let's go with this one. It has little bits poking out of the bottom here, which I think, and I've seen this on multiple cards, I think this is actually what this is meant for. I think that's to show how far up you grind the bevel. I'm not sure, but I think that's what that's for. So I'm gonna have that just extend all the way down to the edge of the card and have the DRC cry about it. So I'm gonna do that. And then up here, I want the solder mask to just slightly cover, actually fairly largely cover the tops of the fingers. We may not be able to get away with that because, well, how does that look on this again? I think this one, yeah, I don't think we can do that. Let's 3D view. It seems like I slightly messed up with the layout because these pads go farther up than the original ones do. So we may not be able to get away with that. But I will rectangularify them, and maybe I can just not have this relief that pokes up there and have just go straight across. Because it kind of goes straight across there, but they poke up a lot more.
Dodgerson says CHEER 100. End of line.
I don't know that one, Dogface, but thank you for the 100 bits. See, test point have solder paste layer because they are SMD. You want to disable the paste layer. Oh, interesting. Well, it won't matter. I just won't send the paste layer to the board house or they'll ignore it because they're not going to do paste. I'm not getting this pre-assembled. Oh, My Little Pony. All right. I wasn't going to get that. Sorry. But this is what the card's looking like. So yeah, we have 3D models too. I forgot about that. That's pretty sweet. I thankfully didn't have to do anything weird with any of them. Like every single board I've made in the past, the 3D models I've always had to like stretch and skew to get them to fit right because I had like weird parts with custom footprints or something like that. There was a part for every single thing here, and they were already attached to the footprint, so that was kind of really nice. Even the crystal like has it's a big crystal, but that's the right size crystal. Once I figured out what the footprint was called. This is a 49/U size crystal, so that's what that is. But yeah, that's really cool. And just for giggles, here's your ray tracing. I was gonna say this runs faster on the Steam Deck, which is weird, except I just remember this is doing it in 4K, so fair enough. But this actually runs impressively quickly on the Steam Deck, the ray tracing.
Dodgerson says CHEER 100. Oh yeah. End of line.
Are you learning how to do that? Because that was pretty good. It speeds up at the edge, yeah, because it's only doing the lighting calculation for the card itself. Any subdivisions that have the card there, yeah, that's looking really good. The backside might look totally different because I adjusted the solder mask properties on the front side. I'm curious here. Yeah, that being solder paste, that makes sense now why it would be like that. I did make the test points SMD pads because I forget why, but I did. I also made them start out as a pad on the opposite side, which is weird. So, both sides look about the same. All right, let's go ahead and close this. So, there's one more thing. I need to get that on a script so I can just hit it. Oh, man. Honestly, thinking about buying the Steam Deck, I like it a lot. So, yeah, I can only be an encouragement. So, all right. There's one more thing I wanted to show you guys, and I don't have the image in here. Holy cow, I had time. Well, the time to follow this project. Your work is excellent. Well, thank you. But, yeah. I'm pretty happy with this. Green Source, thank you for the tier 1 sub and for 6 months. So you just change the test pad in the library once to fix the whole PCB in one go. Yeah, I can do that. On that note, all of the footprints for these no longer have the extraneous solder mask. So if we look here, the only solder mask are the labels, which is good. But there was one other thing I wanted to bring up here. So let's do this. Okay. Much farther down here. This. All right. Der Samlander, or Der Samler, my apologies, sent me this picture. This is of their CM-153 that they have, which is really interesting. It's different. And I don't like that. Starhawk, this is a Steam Deck. It is a computer. It's a PC in the shape of a Nintendo Switch, essentially. So it's pretty awesome. And yeah, that's what it is. It runs Linux. It's awesome. I really like it. So, a Game Boy for rich people. Actually, Bomb Inventions, it's really not that expensive for what you get. I think that it's really affordable. It is less than all of the real game consoles in cost, or just about there, and portable, and like just as powerful, and since it's a PC, it can do everything. Yeah. Looks like a Switch after too much Miracle Grow, yeah. Well, it's got the performance to back it up. It's much better. Anyway, this card here, all right? It has a lot of different traces. Like a lot. And I'm hoping that they're able to... Oh, you're making bad jokes? Okay, that's fine. All right, no problem. They're going to be able to get me some pictures of this. And I'm going to do the same thing with this card that I did with the pictures that I was sent by Roland, who sent me the original card reference material. And I'm going to do this with it. And I'm going to overlay everything. And I want to see what the differences are, because there are some traces we're not really sure about, and some of them take different paths on this card that can be helpful. But I also just want to know maybe what they may have changed to make the card work better, because, yeah, I don't know. Also, one bonus objective I'm thinking about. So I haven't talked about this. I'm not going to recreate any of the certifications, the regulatory markings, but I might recreate this one here, which if I flip this back, where is the mirror tool? Am I blind? It's a pyramid shape poking up. How am I not seeing it? Oh, it's not a pyramid shape. Weird. Okay. So over here is 8934. That means that this card was manufactured in the 89th week, or the 1989 in the 34th week. All right. And that can be corroborated by looking at the production codes on all the chips. Here. So if we look at these, 8931, 8931, 8929, 8929, 8930. So totally 1989 card, which is weird because the drive was from 1985. Mine is manufactured, this one right here, has a manufacture date of May 1986, which I now know makes it a kind of early drive. So these are all really late cards. And one of the things here is on this card, we can see a number down here, 6383.7, and on this card, it is 6383 point nothing, which makes me think this might be a first revision card, and this one is a later revision card. I just noticed there's a mounting hole there that doesn't exist on the other one. So there's another difference. But yeah, there's changes, which is really upsetting to me, just from I put all this effort into redesigning the card, and now I find out there's different cards, and I might need to know more about it, and blah, 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 blah. So yeah, that's it. See, with date stamps on this board, in military meals, dates are often written X week, day, Y of year. Is there a reason for that format I'm not aware of? Probably just to simplify it, get slightly more precise on a 4-digit date. On the later card, they moved a chip for the extra hole. Yeah, so these two chips in the bottom left, actually, let's do it over here. The chips that are here and here have been shifted over a little bit to make room for that hole. Yeah. That explains why they moved them, actually. So now I don't have to wonder if there was like weird signaling issues or something. So, ooh, that's new. I didn't notice that before. Oh, no, it's right here. Okay, I thought that was a trace that they interrupted so they could run another one in the middle or something, but no. Okay. Pigpen Pete, thank you for the Prime sub. Sorry, I missed that. Let's see. Mind you, our affordability, temper your expectations, please, when addressing me, for the fact that I understand Starhawk. It is different for different people. I'm just saying, compared to some PC options, it's really affordable to get a Steam Deck. So, what number of final day is this? Grins, this is the first time I've said it's the final day. So, this is the final day of the whole card. After this, I'm sending it off to get it a couple of things tested, and then I will probably get boards manufactured. Then we'll order parts and do all that stuff, which is going to be very fun. So yeah, all right, we're gonna ignore that this card exists for right now until we have better pictures. I have overlaid the top layer here on a different image, which is really difficult with the perspectives and lens distortion and all that stuff, but I got some information out of it. So yeah, but we will be, this is the final day of the circuit board, because as there are no disconnected nets that I'm aware of. Actually, is there a button for highlighting disconnected nets or going through each one of them? I found out edit, track, and via properties. This is something we're gonna have to do for sure. We have not set net classes and widths and things like that. So we have some really ugly things going on like this, where we have a thicker trace going into a thinner trace. Because I found out, here's what happened, all right? I was using the default net class, or net trace with the 0.275 millimeters, but the default class for the Monster FDC is 0.4 millimeters, which is why we ended up with some slightly different ones. So there is a mixture of different width traces all over this thing. There's a thick one, there's a thin one. So we're gonna have to look at that. I'm going to also have to figure out how I want to do the rail traces. I'm still leaning towards doing ground pores, not ground pores, copper pores for that, just to make sure that they maintain the shape no matter what net classes are set to. But yeah, don't bother with net classes at this point. I mean, it is a little late, but I want the traces fixed. Like, there's some hideous stuff here, like whatever's going on right there, something's not right. What is going on? There, that's fixed now. Perfect. Okay, only 2. Excellent. See, getting everything right the first time would be awesome. Always need at least 2 versions of the board. Yeah, I'm doubtful that I'm going to get it right. There's a lot of unknown things that are going on here So, more TikTok abuse incoming. All right. Just do search and replace with the text editor, change the trace width. I could do that, yeah. Well, actually, the DRC will give warnings when you do traces the wrong sizes. That's working well.
End of line.
That worked very well. I don't think the trace widths are on my notes here. All traces going to passives need adjustment. Ground connection ISA slot has odd copper shape. I have actually added that. I didn't mark it as complete because we're going to do the ISA slot first and then that other stuff. Yeah. All right. Let's start knocking some of these out. Let's just start at the top here. All right. Finish list of point-to-point checks to make. I may have actually finished that already. In the main home part of the repo here, I have a list of all of the point-to-point checks that could be done. So I have two listed as most critical. So there's response, the input buffer, enable lines. So the input buffer enable is this trace right here. I don't actually know that it connects here. We have no way of really knowing that it does because the red traces are under the UART chip. We have no way of seeing them, and there's so many vias on the bottom of the UART that we really don't have enough information to accurately do this. So we're using several factors to try and figure this out, but there's no real one strong thing that we can lean to say this is where this goes. So right now we have it set to DTR, data transmit ready, if I remember correctly, and that would mean that actually DTR is not a good fit, is it? Wouldn't it be data receive ready or something like that? DTR data terminal ready, general purpose, normal use, modem control. Okay, maybe data terminal ready just means that it's ready to receive. Okay, so that makes sense. What that does is it turns on the external input buffer for, let's get the schematic open, because this goes with it. Did I open? Yeah, here we go. So, all right, here's schematic. Let's pop this over here, all right? When we come over to this now, I can select that, and that will activate this. So what we have is a differential buffer right here that receives all of the inputs, and actually there's a separate buffer for the one output for the drive. So all the inputted signals go into this buffer and then go off into the actual circuit to do things. So what the one trace I'm highlighting here does is enable or disable the buffers. So basically it can turn off signals coming into this. Why it would want to do that, I'm not totally sure, but it's wired. There's a trace going to it that is undeniably visible. So let's see, Magicotech, ignore the pin names. They are not used for what they are labeled. DTR is just generic output pin under software control. Oh, that's terrifying. Well, that's even worse than I would rather not know that. So I'm gonna pretend I didn't read that. That's DTR in my mind. Because if that's true, then it could be almost anything. I'm just gonna, yeah, it turns on all the input buffers. Yes, yeah, it doesn't just turn on the clock buffer, and I've tried to correct that in this actually. So this has at one point said the clock buffer, but it now says input buffer. But it's just going into, if I said clock, it's just a slip because I've been calling it that for too long. All of these are connected on all of the input buffers. So it goes to all of them. It's just the symbol for the part goes to the input one. So, see, I've given up with setting up my new phone for this evening. Job for tomorrow. It does take a while to get to grips with minor changes. So yeah, there's that one, and then there's another one, the response pin. The response pin is pin number 1, if I remember right. RXC, yeah. So this one also goes in, and it goes to this blue trace, and we don't really know where this one goes because there are like a handful of places it makes sense for it to go. One of them is to RxD, because response is the only, well, that's not the only. It's a data return probably from the drive, but we don't know fully what it does. I've tried every possible way of finding a protocol analysis of LMSI drives, like looking for service manuals for the many drives that were made like this, and I can find none. So I don't know what the protocol is doing, and I could potentially try and turn on the drive and see if it just goes like high or low or whatever, but I probably won't do a whole lot. Also, we found out that this probably has power going to the external connector, so that's awful. Yeah, it almost certainly does. I hate that. Great. I don't know if it'll show up on the webcam, but right above my finger there is a big fat trace that goes into one of the maintenance only pins. So that would be power going to the drive, because some of the external drives in the later enclosures apparently get their power from the host card. So we sent power into my drive. Yay! Over weird pins that may or may not connect to the input buffer on that end, or yeah. So fun. Actually, they'd be going to the output buffer, wouldn't they? No, because they're the maintenance pins. They're the ones down here that we don't actually know what do. So that's fun. Had to go for a few minutes. No, you didn't really miss anything, David. I'm just going over stuff that I've been talking about in the Discord server. So if you've been reading that, then you'll know. So we're connecting it to RxD because it kind of makes sense for response to go into the UART to be read by the CPU. That's the best we got. I could also see it going to write enable, maybe right here. I think there was maybe a reason that it didn't make sense, but I can see it going to write enable if it just enables or disables the input. So, David, that was the orchestral rise from 2001: Space Odyssey when the monkey picks up the bone. Well, yeah, the monkey's probably correct. DBR signal into the UART. Yeah, that's what I'm saying, Helen Croft. Response could be saying, I'm going to send data, listen now. I could see it being that. That's just active, well, I guess active low, when it's going to send data. But there's no real way of knowing. And the only real reason I suspect that is that it's right here, right next to that pin. But on the other hand, there's no reason for it to be a VIA right there. So that doesn't really make sense. And then this trace actually crosses over right under it. So yeah, is to write data on the UART to the on 8-bit database is on. Oh, okay, I see what you mean, Helen Croft. Okay, so that does not make sense then. Okay, that's good to know. That's only for latching parallel data. Got it. That makes sense. All right. Well, then we're probably right on that, but we still don't really know because it's going under. It's a hidden trace under there. I would like them to also check this trace and what was the other one? Maybe that one. Actually, I don't think we need that one. That one, yeah. These ones we have from context, so we're pretty confident. But that one wouldn't be bad, and that one wouldn't be bad, but would, yeah. I haven't even decided how I'm going to approach them with the email yet. I want them to measure these two, and then I kind of want to say, like, hey, if you're bored and you want to measure all of these, that would be nice. These are, as far as I'm aware, all of the traces that go under chips that we can't identify where they end. So I will double check that at some point here just to make sure. Is that supposedly a protocol analysis here? Yeah, that's the pinout. So Digital Ice Age, this is the pinout of what the connector is, but it doesn't have like a logic analysis time frame. Like here, let me do this. 595. Where is that one at? So this is one that I will understand and can explain to you here. So this is what I was looking at, a timing diagram of what the signal is doing. So here is the clock for the data coming in, and then somewhere, yeah, these would be your actual data signals. So this would be for latching what that data is, and then we have like the full clock. So yeah, this is what I'm looking for. That one's just the pinout. We do have the pinout, which is how we know not there, this. what these signals are right here and what the connector is down here. So we do have the pin out. I appreciate you looking for that though. But yeah, what I need is a timing diagram. That's probably a better way of saying what it is. I need a timing diagram of the protocol to really have a stronger feel. So pin 26 goes to VCC for some reason via backtrace on the backside. Yes, it does. That's the main VCC pin, Dutch Black Cat. So I do have that there. And we have that one marked here. So that one, that's the power rails. I'm not too concerned about knowing whether they go there or not. One thing I could mark on the generally not visible section is all of the traces that we have as no connects or as like signals like this chip right here where we have these all tied high, but those aren't the actual VCC input for the chip. So those wouldn't hurt to check, just make sure that they go to that, but they're kind of a context thing. So yeah, I don't know, there's a lot. it's kind of nerve-wracking to do this without having the card. So yeah, so that's the thing. Okay, let's call that one good enough for now. I will do one last check off stream before I send this over for that, just to make sure I'm happy with that. 2, I've done the test points. Test points are all on the back, so we can call that one done. 3 different mounting holes. We have 1, 2, and 3, and I can never select them on here for some reason. It just doesn't like that. I think it's because, oh, there we go. They're technically through-hole pads, but they have like no angular ring, so that might do some weird stuff. They're not plated though, so disable paste layer for test points. That, yeah, we can do that. It doesn't. I don't think it matters because we're not getting this assembled. So symbol editor. All right, let's look at this. PH.
Dodgerson says CHER 100. Somebody once told me the world is gonna own me. I ate the shower pistol in the shed. End of line.
That was really, really good. And thank you for the 100 bits. LMNOP. Where's my Phillips stuff? Wait, I'm in the symbol editor, not the footprint editor. There we go. Let's see. Maybe someone in the future will make them? That is possible, and there are actually SMD parts on that side, so maybe it would make, yeah, I could see that. All right, let's do this. Test point. Boom. All right. Let's edit. Technical layers. Paste. Let's just, will that be it? Done. Edit. Paste. Okay. So, top copper. There's none. Bottom. Why is this, let's see. Top silk. That is all. Yeah, just edit that. Just disable that. Now update the PCB from the library. Okay. Save.
Dodgerson says CHER 100. Command error in command 3167. Command error in command 6167. Command error in command 74,000.
That's gonna take a while.
167. Command error in command 3167. Command error in command 6167. Command error in command 2333. Command error in command 2167. Command error in command 1167. Command error in command.
It may not, Dogface.
Command error in command 8167. Command error in command 2167.
That's gonna take a long time to get through.
8167. Command error in command 2333. Command error.
So, Dogface, you might have a later revision of Deck Talk. That could be why.
Command error in command 3167. Command error in command.
So mine is like 1996, and the software revisions of it did keep evolving to have more features.
Command error in command 1167. Command error in command 7167. Command error in
Oh, that's
7167.
really interesting. It sent it over serial, so it's actually buffering it there.
Command 6167. Command error in command.
Huh. Yeah, thank you, Helmcroft. Tools, update footprints.
Command 6167.
Boom.
Command error in command 2167. Command error in
we're gonna do this.
3167. Command error in command 6167. Command error in command 74,167.
There we go.
Command error in command 3167. Command
Boom.
error in command 6167. Command error in command 2333. Command error in command 2167.
End of line.
In Starhawk says CHEER 100 bad command or file name.
End of line.
Thank you for the 100 bit, Starhawk. So that's really interesting. It seems like it's caching it on... No, it can't be, because it did the phone call. Did it do more? Oh, that's really weird. Get custom flare as deck talk abuser? I don't think I can do custom flare, or at least I don't know how. I've also never given out any, like, VIPs or anything like that. I haven't decided what I want to do with that. It's really weird with it being limited. Like, I feel like you're either a mod or a viewer, and I don't understand the distinction. Okay. Redemption time. I don't. Oh. All right. So test points are done. That was a long serial.
In the town where I was born lived a man who sailed the sea, and he told us of his life in the land of submarines.
End of line.
That was really good. I think the deck talk errors are just your background sounds. Yeah, that was really good though. Okay, so test points are corrected. 3 different mounting holes, those are good. ISA card edge pads. You know what? I did not totally fix that. Let's work on that. So I'm going to, and I want the whole thing. Edit footprint. We're gonna go ahead and save this footprint this time. I don't think I saved it last time. So, let's go over to the schematic here. That is 32.
CHEER 100. Can someone tell me where the start of the line is? All I get told is
End of line.
Thank you for the 100 bits, Spots of Mud. Oh, how did that happen? Oh, that's right. ISA is awesome. It's just 100 mil pitch, isn't it? Yeah, I like ISA. Anyway, pad number 32. Okay. Now, this is the part that might suck. Pad properties. Pad type, edge connector. I didn't know that was a thing. Ooh. Interesting. Then it should know? Oh, I bet. Thoughts, brain, things. I think I remember what part of the problem is. You're supposed to put edge cuts in this, and they didn't for the Monster FTC. So we might do that here. Tools. How are we gonna...
Rasmus McDodgerson says CHEER 100.
End of line.
That also worked really well. Are you using the MIDI one for that? You know, now that I think about it, if you can find MIDIs that have, like, the vocal part that get played by an instrument, convert that to a deck talk track, and then put in the phonemes, you can have it automate how things sound when they're sung. Is that how you're doing that? Yeah, we're gonna have to do some stuff here. All right, let's save this file Save as. It's so tiny. Footprint is just text file. Yeah, but it's not saved into a specific footprint file yet. So let me do that. Phillips ISA. Actually, reduced ISA. All right. But I do them all the time with my work stuff. Phonemes are hard. Oh, interesting. Okay. So I found a key pitch map, then I use a Python script that I can. Ooh, okay, interesting. Huh? And then you just adjust the durations. Okay. Let's see. Looks like I missed a couple of songs. Yeah. At least it doesn't have pals. Yeah. No, this thing's super simple compared to how bad it could be. All right. Now let's do this. Edit. Change footprint. And I'm going to change it to, yeah, that's fine, whatever. Reduced ISA, boom, change. All right, close. Okay, perfect. So now we have the non-existent pad back. So there's that. Now we're going to change some other stuff. So let's save this, close it. We're gonna do this manually. EDA. You know what? Actually, hold on. No, I'm going to open that back up. Here, footprint editor. I want to do a couple of things. Phillips shapes, reduced ISA. All right, we're going to use pin 32 here as a guinea pig. We're going to make it regular rectangle. Boom. And I don't know. There is a search on the top of the list. Edit one pad in the editor. Yeah, that's what I'm doing now, Helen Croft, so that I can use this to figure out what I'm going to change. Yeah, so I don't think I'm going to be able to get away with moving these up, because on the back side there are traces that go down, and they would, well, I just guess that wouldn't collide since there's no pads over there. I think I'm just going to not change the height. That's too much, but I will attempt to lower the solder mask down, so we have a little tiny bit of solder mask on the top of those. That's my goal there. So we'll leave that, but I'll save that one as rectangular. Now let's go check this out. Shapes, pretty. Reduced ISA. Okay, we're gonna go into here. Open. Ooh, that's interesting. All right, we'll go with that. That way you guys can actually see this. All right, Vim, R, reduced ISA. Okay, perfect. Oh, these are big. Okay. Where's the pad number? 32, rect. Okay, so I'm going to need to change a bunch. So we need to change round rect to rect, and then remove everything. Actually, I guess these are all the same. So I could just save that before I ruin it. All right, let's do a couple of things here. Okay, so we're gonna input buffer. We're gonna substitute, copy, paste this. I don't remember if I'm gonna have to escape parentheses. I don't think so. Looks like we are. Some interesting stuff happened there. All right, buffer, substitute, escape, parenthesis, parenthesis. Boom. Still didn't load quick. Do I have to do...
Says CHER 100.
End of line.
Getting really complicated with them now. Why is this not working? Hold on. Buffer, substitute, round, rect. I gotta have this. I don't know. Wait, it's not this, that, is it? No. What's going on here? Buffer, substitute. What is going on? Yeah, you guys can see it. How am I screwing this up? Alright, let's just Google this. I should know this. This is just regular expression. Yeah, buffer, that's what I'm doing. Like, look, I don't know what this / is. I can't get rid of that. Wait a minute, I'm an idiot. That's right, there's... Brain, how did you switch to Minecraft commands? Jeez. Okay. Let's do that. Trailing character. And that should be a G. There was something, finally. Alright, we got rid of those. Now let's do round rect. Bleh. Round rect will get replaced with rect. Boom. Alright. Now, does 32 look indistinguishable from the others? It does. Alright. Save. I'm going to leave that there. We're going to go back up. Reopen this. Footprint editor. I want to see it. Reduced ISA. They all look great. Excellent. Ah, that's nice. Okay. Dual space. If that happened, it doesn't matter by the looks of it. Search at top. What do you mean search? Oh, there. Yeah, I could do that. Okay. So I'm happy with that. Mostly. Mask. Front mask. So that's just over the pads. So is it because it's marked as an edge connector that it's marking the whole thing as that? What is the magenta? Margin, courtyard, there we go. So courtyard is just supposed to be an area for when you're laying out the PCB that basically says don't put anything in here. This is not edge cuts. So what I think I'm gonna do, I'm gonna select these lines here. You know what, maybe not that one. Let's grab this one, that one, and that one. I'm gonna copy those, and I'm gonna paste those in to edge cuts. Boom. I'm gonna hide courtyard, come back to, okay, we're gonna edit these. If it'll let me. Maybe big solder mask just on the PCB itself. I will check to see if there's something like that. Yeah, I'm not sure. Is there a different way to move them to another? Am I gonna have to do these one at a time? Is that what this is? Hold on. Edge cuts. I'm hoping marking these as edge cuts is going to make this show up correctly as a card edge connector. And I'm pretty sure, I will double check here before I finish this, that the Phillips card does not have chamfered edges like this does. It may have beveled, but it's not fancy pants round edges, that's for sure. I think it's just square. Oh, that's really hard to tell. Yeah, it's just square. Boom, straight down. So we're gonna go square on that. Make it slightly harder to align, and I might just kind of squish them in just a tad, just to make sure that they'll align. Nah, probably, you know what? Nah, I'm not gonna mess with it. This is probably good. So. And edge cuts, brain, blip. There we go. Now I can select all of these and move them into, seriously. Well, that's gonna make this complicated. Eh. All right. Let's hide courtyard. Boom. Okay. I think that's the correct way to do this. Alt 3. That looks like a thing. I'm not quite sure what's going on there, but all right. Hey, this doesn't have solder mask relief on it. Okay, interesting. So let's save that. Now I'm going to try and update the PCB. See what that looks like. Oh, there's a giant thing. Yeah, it's got front and back mask on there. Okay, so we can just modify. Well, no, I want to modify the actual edge connector. We'll move these over to the edge connector rather than do this. So, all right. But a couple of things here. Let's grab this. Boom. Okay. Update footprint. Is that all I got to do? Update. Boom. Perfect. Okay. Now that brings its own edge cuts now. So what I need to do is I need to... I'm going to hide the courtyard again because that's driving me nuts. We're going to select these. Please let me... I'm going to do this. Nope. Come on. Oh my gosh. Stupid. Wait, is there a non-grid alignment option for the cursor? It does not look like it. Because I can't... Wait, why can't I select any of these? Oh, because I'm on the copper layer. Durr. There we go. Delete. That might be interesting. We'll see what happens there. I might need to get rid of that. Delete. Delete. Or move that down slightly. That could be problematic. Delete, delete. Okay, we're making some interesting changes here. Alt F3. That's not good. All right. So let's just start by going up here and then moving. Oh, that was so not what I wanted. One moment. Let's bring up some grid again here. Just want to move this down a little bit so maybe the endpoints go where they're supposed to. Edge cuts. Okay, I'm going to try and drag this over that badly so that they just align there and then try this. So there. Okay. Alt F3. Nope, still doesn't work. Well, huh, okay. I thought that was the way you did it. Turns out not. Sure, edge cuts belong in the footprint in KiCad. I thought that was how you specifically marked edge connectors. I thought that was part of it. Like, as far as Gerbers are concerned, that'll be put into the Gerber as an edge cut. Like, I bet. File, fabrication, Gerbers, plot, sure, whatever, I don't care. Refill, drill, close, okay. Now if we go to, not that, Gerber viewer, how does it not just open the Gerbers that are in the folder that it defaults to? Come on. There we go. Yep, it did it. Yeah, see, that works. And that's what I would expect working the 3D view, but no. So, because that's how the card's going to look when it's done. There is not going to be a 3D view here because it's just not what it's meant to do. But yeah, so that'll be the correct edge dimensions. I haven't put edge cuts in a footprint before either, but I've also never done a card edge. So looking up card edge connectors in KiCad is an infuriating process that is just a big waste of time because it's everybody asking how do you provide card edge cut specifications to the board manufacturers, which you don't really do. So yeah, but all right, we're gonna undo everything I just did there. Alrighty, and that reset that. So let's go back to the footprint editor. Boom, and we're gonna delete everything we put in the, delete everything we put in the card edge, or board edge cuts thing. Courtyard, hide, edge cuts, there, select, delete, select, delete, okay, save. I've done quite a few card edge connectors in both, let's see, which software are you using? This is KiCad, K-I-C-A-D. And hello, Soviet Monkey Pie, since it's your first time chatting. See, I've done quite a few card edge connectors, most of the custom, because a lot of what I work with isn't common at all. I even did my own ISA footprint because of all the ones found that were wrong in one way or another. That's funny. There actually is here, let me save this, a KiCad ISA connector, but it's full for a full 16-bit, so we could hack that off and then just use this. You know what? Do they have anything in edge cuts? I think they do. Nope, that's in Fab. Okay, let's hide Fab. All right, so they don't have anything in edge cuts. Okay. Interesting. Yeah, maybe I don't know then. Weird. Let's go back to this. So edge cuts is just board outline. Yeah, it is. Oh, you can put stuff like internal routes in there too. So that's why it's edge cuts, not just board outline. Well, I mean, it technically would be kind of an inner outline. I don't know, it's weird. Anyway, bring back courtyard. Okay, anything else? Yeah, we want to put the masks in here. So front mask, let's do this. Big ol' fill here. Yoink. We probably want to like actually align this correctly to the graphical representation, don't we? Dang. All right, so let's zoom this in. Step one that I frequently forget is to rotate this. You would think I would just do that in the image, but I just do this and then forget about it for a while, so this works out too. All right, that's 150. Now I need to make this semi-transparent. Boom. And let's work on scaling this so this all lines up. Yay! All right, so 150. Let's try. Oh wait, hold on. I gotta make this one sit on top.
Pt6
I know you are afraid. fear has consumed your entire lives. It has enslaved you, blinded you, lied to you. The tyranny of your emotions has been absolute. But we can free you from this madness. Salvation will be yours. We have chosen this era carefully. Earth is already in a state of heightened emotional turmoil. Collective anxieties have never been greater. Mass hysteria will be accomplished with these. End of line.
I don't know what that's from, but that's interesting. Okay, I think that looks like that's probably good. All right, so let's push that down there. Okay, that's interesting. Wait, does this already kind of poke up enough? I don't know. Well, let's just go with that, see what happens. Actually, no. I want to see the PCB view again. Where is this going? Is the bottom edge of the board like way too high up? What's going on? Yeah, it's really close to the Cylon's HMS Tower Bridge. Yeah. How were they done? Ugh. They definitely didn't use a deck talk. That's gonna happen, David. Yeah. I'm now concerned about the alignment. Well, no, it wasn't a deck talk. No. It was what, 1978 for the original run? Yeah, it's gotta be 78. Ring modulator. Ah, interesting. Anyway, I think the card edge connector is kind of weird. I don't. So, on a card edge connector, the contacts are they poke in, all right, and they touch the card towards the top. And then there's more at the bottom. It is theoretically possible that the card, the CM-153, doesn't have an edge connector that goes as far down as it could. And is kind of like shifted up. Because now I'm really concerned about how I aligned all this stuff. Because this card edge connector goes much, much farther down than it does in the image, now that I'm seeing this. I don't think it'll matter, but, Give me one moment. I might be about to do something dumb. Seriously, Amazon, oh my gosh. One moment here. Seriously.
Says CHER 100. Oh yeah.
Open Amazon, it goes straight to an advertisement for their new television show, full screen. Wow. Lame. Yeah, I am. Don't worry. it's done. Oh man, this is in-app Starhawk. It's done. I just bought a 3090. You can get it on payments for less than $200 a month. All right. There's a thing here I want to do. I don't know if I can do it. I don't know if I can do this from my phone. Yeah, that's gonna change some video editing stuff. I've been waiting for it to go down to a particular price, and it did. Let's see. Good decisions were clearly made. Yeah. Anyway, I will do. We'll do that after stream here. All right. Yeah, Dogface. Yeah. For 42 months? Nope, 5. Anyway, okay, let's see here. Measure the edge connector of the 16-bit card. That's a good point. Let's do that. Okay, so drawing here, all right, we're gonna go, actually, let's fix the pad spacing. So bottom to top, so it's 8.128 millimeters for those, all right. For this, it is, and for the record, these are rectangular. I didn't change that. It is 7.62. Okay. It looks like this is supposed to show where the card is. So let's say that is 8.95. All right, let's go back to this. This is kind of as close as we're gonna get here. So here, no, this thing, all right, there to, come on. We can do this, or Y only is 8.826. So, is it 8.925, 8.826? So it is a 1/10 of an inch shorter.
Galinax says CHEER 100 ba 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 ba.
End of line.
Oh, that's so familiar. Oh, what is that? Also, thank you for the 100 bits, M3J Linux. Good evening, all. Are we done yet? It's Lars. We're kind of done. It would work, probably, pending no errors with how we've assumed everything is. Right now, we're doing finishing touches and trying to make it nice. So that's kind of what we're doing. Close Encounters. That's it. That's a good one. That was, that's excellent. All right, we're gonna just not worry about it. I don't know, just hope for the best, because if the Monster FDC works, this probably works. So, yeah. Anyway, let's just, So these poke up slightly to right there, let's say. So I'm gonna put the solder mask relief F mask rectangle from here to there. And we're gonna edit that and fill. Boom. Okay. Now we're going to select, copy, paste, edit, and go B-mask. Boom. Okay. Alt F3 for 3D, view, and there we have our solder mask relief. I don't know why there's this weird one thing there. Maybe there was a pad that was not in there.
CHER 100.
End of line.
It's large. Thank you for the 100 bits. Okay, we got some weird extra pads with no corresponding actual ones. Let's hide the back. Okay, so and here looks like these are. No, those are all where things are. Okay, I think we're good now. Yeah, I think we're good. Okay, so 3. Nope, there's extras on the backside. Let's hide front copper and front mask. There we go. So we got 4. Wait a second. Are you using KDE's ability to add translucency to the window? You figured it out, Troutbridge. That is exactly what I'm doing. I'm making the window transparent to align the contacts to that, because KiCad doesn't have the ability to arbitrarily add reference images. So yeah, that's what I'm doing. 3D footprint, add a border. What do you mean a border? You want me to put like a silk screen of where the card edge is? Is that it? Anyway, let's select. No. No. Not all items. Graphics? Dimensions, zones. Okay, let's try this. Boom. How do I select that? It's not a footprint. Is it? Man. Still can't select it. What? Wait, these don't have a bottom mask, do they? F mask? No. Why? Why are these here? 3D view adds border around footprint. That's why you see the solder mask. Oh yeah, no, I'm not worried about it looking weird. I'm worried about these little bits in the solder mask right there. Those should not exist. So I'm trying to figure out what I need to do to remove those. That's what I'm doing. It looks like it's these, but then I try to click them and it selects the stuff on the top layer. Unless I'm on the top layer. Pad. That? Ha! Well, I don't know why that changed. But let's do this. No net, boom, and boom. Perfect. Okay, that's fixed. Okay, might be able to go with this now. Close that. Go back to this. Update footprint. Actually, hold on. Let's not do that yet. Let's F mask, delete, B mask. Delete. Okay. Update footprint. Update. Haha. 3D view. Actually, we gotta close this. 3D view. Boom. Little. Oh, I gotta. Uh-oh. Yeah, those have. They have their own mask. Oh, I just have to disable the solder mask on all of the pads. Okay. We can do that. This might be another text editor thing. Also, this is now wrong. Load file. So, let's go with, what is this pad? No net. That's interesting. Close that. We're done with that for right now. Open this. Footprint editor. ISA. I don't know how I didn't think about that when I was looking directly at these. All right. Fmask, read that. Okay. Edit. I can't, like, select all and edit, can I? Because that would be real handy. Edit. Remove the XBAT mask bit. Oh, okay. Well, layers. So if I just remove, whoops, undo. All right, let's try this. Open that. Nothing. F dot mask. Boom. That's quote F dot mask. Okay. I'm wondering if it's gonna like weird it out by having the layers thing there with nothing there, but we'll find out. Right. Okay. Now let's reopen it. Boom. It doesn't like that. Let's close it. Reopen here. Add the quotes and space. Well, there's a space. That's, yeah. You know what I should have done? I should have not, I should have backed it up. Now it's gone. It says, no thank you. Oops. Undo, undo. Right. Footprint. You know what? Duh. There's a very easy solution. ISA. Now it's there. Okay. So open this. Let's just remove this whole thing. And I'll remove your space this time. Boom. Right. Go back. Bingo. Oh, they're weird colors now. What? Copper should be... Is copper yellow, not red? That doesn't make sense. Well, yeah, we'll find out. Edit.
Contact says CHEER 100.
What piece of work is a man? How noble in reason, how infinite in faculties, informant moving, how express and admirable in action, how like an angel in apprehension, how like a god, the beauty of the world, the paragon of animals, and yet, to me, what is this quintessence of dust? End of line.
Another reference I don't know. All right, and no dice. Really? Really? Is it just like putting mask over all pads? Oh, it's Shakespeare. Okay, that explains it. Okay, let's hide copper. Hide rear. Okay. Silk screen. No, that silk screen doesn't matter. Mask. And mask. What are these yellow ones? All right, let's do this. Let's open this. Edit. Now it's on both. What? How is... That's not what I wanted. Alt 3. So you're telling me these are poking through? No? What? Wait, what is pad E? What? Edit. Oh, did I change the number? Uh-oh. Undo. Okay. But yeah, now they're on both. All right, let's do this. Cancel. Okay. Select. Edit. No, no. Okay. Go back to this. Actually, let's save. Let's go back to this. Come on, figure it out. It got edited. Please open it. You remove the copper layer, so it's weirded out. Did I remove the copper layer? What? Undo. Layers. Oh, I did do that, huh? All right, that's fair. Do not load file. Right. Yes. Back to normal. Okay. You know what doesn't take that long to do? Just doing this. I failed at the automation. It's gonna take me longer to do that. And it will to just do it manually. What is a change in the text? That is a good question. Let's see, is this going to notice that it's actually been loaded? You know what, let's just do this. Boom. Okay. Layers, B, mask for just those. You know, do I want to delete those? We did 32, and now 32 still has it. Oh, because I haven't saved it yet. Save. Or did I? There we go. Load. Yeah, it just shows the copper layer, but that's what I did at first, I think. I don't know. Oh, well. Select, edit, mask. Select, edit, mask. Select, edit, mask. I'm just doing this. I'm just doing it GUI. It's slow, but you know what? It will work. I like automating things as much or probably more than the next person if you see my cron jobs on my server. But this just needs to be done. Is that it for bottom?
Says CHER 180.21.01. Was the
Ooh.
what?
Yeah, that makes sense. I'm gonna let that ring for a moment.
You get signal what? Main screen turn on it's you. How are you, gentlemen? All your base are belong to us you are on the way to destruction what you say. You have no chance to survive, make your time ha 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 captain. Take off every zig. You know what you doing move zig for great justice
End of line.
Thank you for letting me know. That is weird. Let me try. Oh wait, OBS crashed. Oh, that's weird. Why did it crash? All right, well, that'll fix it. I don't even have to get up. I know the joke reference, Starhawk, but I don't actually know what it's from. I want to say like Zeta Wing, maybe? I don't know. I'm just guessing a name, because I think it's something that you wouldn't expect. It's like a weird shooter game thing. And by shooter, I mean shmup. Zero Wing. I was close for not actually knowing. I'm pretty happy with that, yes. And thank you for the 100 bits, Starhawk. Okay, save. Over to this. Click. Update, footprint. Do the thing. Close. I deleted the things, but then I also left one pad with solder mask. Wait, no, it's what? So there's more hidden ones. Cool. Here and there. Aha! No, let me select the thing. Footprints. Nope. Pads. Wait, footprints but not pads? Man, how did I do this last time? I know it happened. I reverted changes on this, and it's before I added the masks layers. So that's what it is. But I need to figure out how to delete those. I don't know why it's being so mean. Like, why can't I just click that? Doesn't make any sense. Okay, rear mask. You know what? We're doing this. Save. Here. They're all of these ones up here. Load. Actually, let's do this. Open that. Go here. Delete. Save. Boom. Alt F3. They're all covered. Okay. Close. Add the mask layer drawing rectangle. It was something like right here. It's gonna be, nope, not a polygon, a rectangle. It's gonna be close enough. I'm gonna widen that just a little bit. All right, edit. Fill. Okay. Copy, paste, edit, bottom, okay, save. We're almost there. This is the dumbest problem so far. Not edit, no. One moment, right click, update, boom. Oh, look at that. Was that so hard, KiCad? I need to move it just slightly down. Like, just slightly. That's too much, I bet. Save. Let's put this over here. Right click. Update. That was too much.
Context says CHER 100. Celebrate your oddities, your work, your sexuality. Celebrate your urges, celebrate humanity, celebrate your fetishes.
Yeah, Helen Croft.
There's no such thing as no mel. Everybody's weird. Celebrate your oddities, your art, your own insanity. Celebrate your birth, celebrate humanity. Celebrate your everything. And let me be clear, there's no such thing as normal. Everybody's weird.
End of line.
Thank you for the 100 bits, Manchenko Tech. There we go. What's with the dot clock? Dot clock. Oh, the dot. When you put in too many bits of punctuation, it kind of gets weirded out. That's what it is. That's done. All right, we're calling that good enough. It's not 100% accurate, but it's pretty close. So we're gonna go with that. All right, what's next? So save. Okay. Load, sure. You know what? I think we can quit that. Get status. I don't think that file is tracked, so let's go ahead and add that. Git add reduced mod. There we go. Okay. Backside pad's not on the. Hold on. Okay. Backside pads not on the edge. They should be. Yeah, I think they are. The thing here is on the edge. These are going up to the edge. I'm giving up on the little bit that pokes down, so I'm gonna just say nah, it's not worth it. 3D was messing it up. Oh yeah, it's kind of weird. The PCB, the FR4 itself is transparent, so like you can see that there. So when I zoomed in, it might have been at an angle that made it look weird. Yeah, it's probably something like that or something. Yeah. So, yeah, I think they do it intentionally because actually kind of what we can see there, you can see the vias inside, maybe like that, and then the capacitor underneath. You can get a weird angle in here. Like, I'm totally not wasting time. Ray trace. Is there going to be a reflection of the capacitor? This is a lot harder angle for it. Good time to get some water. There are reflections. The capacitor doesn't have it, but you can totally see reflections of the legs. Oh my gosh, that's awesome. See, the poke down bits are added by the board fab to plate the fingers. Ah, okay, that makes sense. POV, your fly 1990s PCB manufacturing company, yeah. Oh, that's cool. I like that. And there's like a texture to the solder mask. It's not just flat. Ah, it's nice. Good software is good. All right, git, commit.
Context says CHER 100. Today's water is brought to you by Linode and the letter W.
End of line.
Thank you for 100 bits, Benjego Tech. That is a fiberglass weave. Yeah, because it's not flat. Yes, it's just cool that they have it. All right, final ISA connector. Git push. All right. Let's see. No. Where? Oh yeah, that goes over here. So next, okay. X-Tall mounting holes. Those are done. Let me just double check the traces here. Oh, that's kind of ugly. Hold on. Let's fix this. That. You. Just delete. Wait, does that not go anywhere now? There. Boom. Hopefully that's all good. Okay, that looks better now. I think that goes up weirdly like that. The position of this resistor, this is all horrible. Actually, yeah, we're gonna get into that later. We'll fix all that later. But that looks better, I think. Let's, how do I keep closing GIMP? Card sides. Let's see, yeah, definitely. Thank you, Ohms, for the gift sub to Hellencroft. And see, KiCad support rendering 3D view with ray tracing, such a niche. Yeah, but Lars, it's not RTX, so you can do that on the Steam Deck too. I have actually done that, so it's like a thing. Not that like everyone's like, oh my gosh, it's KiCad on the Steam Deck, it's so awesome. I would totally want to do that, but it can do it because it's AMD. That's why I'm pointing it out. So, all right, let's look at this. Oh wait, it is the backside. That's where all the fun stuff is. Okay, yeah, that's kind of awful. So. All right, so mine's not too far off, excuse me, by also being awful, but we'll fix this. I have a note for fixing all the SMD stuff. Theirs is not as bad as mine is, so we'll fix that in a little bit here, but yeah. So, I run KiCad on a Raspberry Pi 4. Ooh, probably runs okay on that. So, okay, we can definitely say 2 is done, so we'll go with that. All right, determine passive values. That was a long one.
100 minutes, a hot one, like 7 inches from the midday sun. I hear you whisper and that word smelt everyone, but just ain't so cool. I'm on Akita.
End of line.
I don't know that song, but thank you for the 100 bits. Okay, so we're gonna be adding, actually we're done with the PCB part for right now. Let's close this. We're gonna be adding values to the passive components, which is going to mean getting capacitor values and picking an actual literal crystal. I have some plans for this. We'll go over that. Let's finish all the resistors first. So Hellencroft has actually been working on this, and I don't know how far it is. So I'm just gonna poke around here. It looks like it might be done actually. Really. All resistors are done. Whoa, awesome then. Thank you. Okay. In that case, let's do this. I'm gonna pull that out. All right. I just need to make sure. Well, this is a thing. So we have 4 capacitors here that are weird colors. What do we think the chances are they're lazy and they just used all the same values? Because, yeah, so these ones, these 3 brown ones here, nope. Fun. I really don't know what's going on with that one. I don't like that one. I really don't like that one. Which is that one. I was going to click the image so it would bring it up over here. That does not work. I can open this and move it using the desktop manager stuff, and then click that. Oh, it was the one I was looking at. Okay. So, oh, that's awful. Well, what about this one, Hallicroft? Because this one's a little different. Well, the way that they're connected, Irondale, they're all connected to like ground or something. So unless they're like really, really weird Zener diodes that are trying to clamp a voltage or something, I'm pretty confident that they're all capacitors, because there's no way you didn't connect an inductor to ground. Yeah, but if they're an RC time delay, then that means that this could be any value that they calculated that they actually needed. $1K is pretty simple. Yeah. Cool. Yeah, but what I'm saying is that they're the same, I mean, the lame thing I'm saying is that they're in the same color as the other ones. So I feel like, well, now that one's slightly green, these ones are slightly, you know what, let's do a white balance on this. Color temperature. Where did that open? There it is. I think basically go all the way. Yeah, they're kind of the same color. Maybe these are slightly more yellow. It's just hard to tell. But anyway, I was just trying to see if they were like lazy and they just use the same parts. Yeah, you'd start experimenting. Fun. I don't like doing that, but we're probably gonna have to because we have no idea. I will mark this.
End of line.
That sounds like it's probably a national anthem just by the grandeur nature of it. I have no idea what. Thank you for the 100 bits, though. If it is, it's a very weird one to pick right now. Yeah, David, that's, yeah. All right, note made about C4 arbitrarily designated capacitor on the schematic. Because, yeah, we're probably not going to do that, be able to get that one. We have an informal ban on Comrade mode and some Discord servers. Yeah, I can understand that. Yeah, there's really not a lot we can do about that one. All the other ones, though, with the exception of also this one, which is another RC circuit. All right, let's... Yep. Let me add that one to the same exact thing. Where's that? Which one's that one? C7. It is identical. Okay, let me just update the same. Ampersand C7. Spelling as well. All right, there. Different resistor value. It is indeed fun. Oh, you know, well, no, I was gonna say that one's probably just debounce, but no. I bet it is a debounce still, but we, oh wait, no, that goes into the capacitor. What? The capacitor crystal, why are they filtering the crystal output? Is that a thing? Like, are you trying to get like a really slow rising falling edge? Why would you do that? I would think you would want that to be as hard as possible to get like a really solid on-off time. Oh, it's a filter for harmonics. Okay, that makes a lot of sense. Oh, all right. So that's probably a very, very small value then. Yeah, low PF range. Yeah, okay. It might even work with it omitted, I bet. But yeah, all right. It's a shame you can't just buy capacitor pots, because that would be really nice to just like stick one on there, wiggle it around until it works. It's also gonna suck to have two to have to do, but oh well. You can buy trimmer caps. Oh, that's right. They're the weird ones that like stick straight up and then a screwdriver that you poke down in. That is right. Okay. I know what this one's gonna be. And I don't... Oh, nope.
The world is gonna roll me. I ate the sharpest tool in the shed. She was looking kind of dumb with her finger and her thumb in the shape.
And the line.
And the flight's still good. Thank you for the 100 bits, David. That one did work well. All right, well, we're gonna 100 nanofarad the other caps, so let's just do that. We're down here. So edit, value, 100 NF, boom. Oh, that's right, these are all 1206. Dang. I was gonna say, I have a reel full of 100 nanofarad Samsung caps that we can just use, but they're 0603. They might fit, but it would be kind of a pain. All right, so save. Yeah, we're just gonna 100 nanofarad that. 0.1 mic. If you prefer that unit. All right, clock caps. Let's do this. This means we're gonna pick a capacitor here. So, give me a moment with no capture. let me disable this. Tools, because I'm going to open my email here for a moment. NDI, off. All right, no movement, not doing stuff. Boom, boom, yeah, okay. Alrighty, here, just give me a few seconds to check some things. Let's see, 100,000 peak. Yeah. Alrighty, doing a couple of other things I actually kind of need to do here. So give me a moment. Boom. Boom. All right. And where is it? There it is. Copy. Over to here. Paste. Well, it's a bit late, Ryan. I'm going to wish you well. Catch up next stream. All right, I will see you later, Chout76. Next stream, we're going to be doing anything else other than this. I actually have any idea what it's going to be, but it's not going to be this. That's all I can tell you. This has been all that I could think about for like, what, 2-3 weeks now? I am so done with this. So, yeah. Yeah. Let's see, let me do that. All right, bringing this back. Tools, NDI output, and click. Is it back? Okay. What we got going on here? Woo. All right, perfect. Okay, nope, it's not gonna be data generals. Oh yeah, the CPM thing. So Starhawk, I don't know if you're a patron or not, and that's not a like try to push you into that or anything. Patrons have had access to a longer cut of that video, and the last video I put out today. So the CPM thing, okay. Part of the video I did on the keyboard, I cut this out, but most key switch pullers that you can buy on like Amazon or whatever are actually dip IC pullers. And in some cut footage from the video, I demonstrated this on the CPM thing that you sent me by just quickly pulling an IC off to go, hey, here's how it works. And then I looked on the bottom of it and there was a leg crunched up under the chip. And then I was like, oh, that's not right. So I bent it flat, and then I looked at it again, and I found out that this IC here, which is probably the Z80. It's a big 40-pin dip that's not the Atmega, but it's the Mostech from 1983 that's labeled Tandy Corporation. Man, there's a whole lot going on with that thing. Weird. Anyway, that one was offset by 1. So I moved that over. I have not lifted all of the other chips to determine if they are, if they have any crooked legs, and I will probably do something like that or look down and make sure that they all look like they're going straight, but I may have fixed it already, accidentally. So maybe, I don't know. I'll have to look at it, see if it's got, because I don't know anything about it. So we'll have to see, but possibly. Can do Patreon? Yeah, it's not a push to that. I'm just saying that there was an extended cut of the video that had that. So yeah, maybe something Radio Shack. Yeah, it might have been pulled. Oh man, it could technically be Septandy. That would be hilarious. Yeah, I'm actually done with all of the theme months. I've only done Septandy, but I'm not interested in doing more themed months. So potentially, I'm not saying that that's what it's gonna be, but maybe just powering it up and seeing what it does is on the table. So yeah. Alrighty. Alright, so what I have here is a DigiKey search for the specific form factor HC49U crystals. These are what fit in the footprint of the board. So what I need to do now is pick one of these. November. oh man. Oh, I wish I could just make a Nova video happen. That would be kind of amazing to do, but I really, really can't. Anyway, so what we have to do here, all right, is I have to think that I needed to open a link in over here. Not that. This, because we need a math thing. Copy. Close. Alrighty. Crystal with a lot of stock. Oh, pick a crystal with a lot of stock. Yeah, because I don't know how to like judge the variance of them, and I don't know if it matters. 5 megahertz is pretty easy. But yeah, so right here is a column that you absolutely will not have any hope of being able to read. That is load capacitance. So you would think like, oh, that's just the value of the capacitor you put there, but it's not. That would be too easy. I think the rough value is double that, but what we're gonna do is we're gonna look at this Adafruit page that gives you the formula, right there. That's the magic that's going on. All right. And we have to say that it's the capacitor values plus some random value that we're going to guess with. That's the capacitance of the PCB. And it's funny because they say like you really shouldn't have your crystal going through any vias or stuff, and it's like you probably want them to be like trace matched, you know, for the length of the traces. But Phillips said, nah, let's just do whatever. So one of the traces is going through a via and literally wraps over the other one. Both of them, well, they have to go through vias to get into that, but yeah, so one of them is almost twice as long as the other one, and then it goes through a via. So yeah, that one is garbage, but the other one is just fine. So this could be really tight for it to work. I don't know. So we're gonna order like 3 different values with that are roughly equivalent, but similar. So yeah. Let's see. By the way, if you're able to take non-Patreon support through incompatible means as recurring PayPal invoice, love to pitch in. I do Patreon incompatible, just not actual brand name Patreon. If you have my email, go to techtangents.net. And then there's a support link on there, and I have a PayPal monthly payment thing set up already that you can just put in a number, if that's what you're talking about. And then there's a Ko-Fi monthly option as well that you can find through there. I don't know how that one works. I'm not personally, no one's done that, so I'm not sure if it's like specific day of month or anything, but you could look into that. But yeah, those are the only options that I really have available right now. But the PayPal one, I think it will just start whenever you start it, so you could pick. So, they could have flipped the crystal in the original schematics so they didn't need the via. Yeah, right? But we're going to clone it. Stupidity and all. Actually, you know what? I want to go back to here. Did they do that on this one? On the other one? Nope, still goes through a via. They didn't fix it. That's great. Oh, wait. No, yeah, no, they didn't fix it. PayPal link does not seem to work. 403 forbidden. Let me just, I'll double check here real quick, like. Where is it? Let's see, let's move that down. Hard to multi-monitor on one monitor. Let's see. techtangents.net. At those frequencies, it doesn't matter? Yeah, probably. Let's see. Info, support. 1. You know what? It's going to log me in. That looked like it was going to work. I just realized I shouldn't do that on stream because it might show stuff like an address. Let me disable OBS again, and then I will test it and show you. But that might have just shown you whether or not it was going to work too. But yeah, let me just do this real quick, like. Okay, disabled. It's doing a robot security challenge. Logging in. Da 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 da. Okay, so I think it will work. It errors for me because I am the same account that it would go to, and it's telling me like you can't do that. So I don't know. Did you just put in? Let me bring it back up here now. So did you just put a number in here and then click the donate link? Or did you click this? Oh, that might be broken. I don't know about that. PayPal.me/ yeah, that could be it. But the PayPal monthly here, that's the thing that would do that. And I'll just throw this out there for anyone. Well, David, so here's the thing. This only works because it generates a custom URL on demand to make a subscription that works like this. It's kind of weird to get it working, and I had to rip off this code from somewhere else to do it. So yeah, clicked the button, it took me to another page that says send 403. When I click send the button, okay, so you went through the PayPal monthly thing. Okay, I will have to look into that, maybe get someone else I know to run it on their computer in front of me or something. So I'll try and figure that out. But once this is working or not, just throwing it out there, this is literally the best way that you can support throughout any service, because this one takes the least cut. You can also do it through Ko-Fi, because that one has like a monthly option as well. So if you just hate PayPal, you can go through Ko-Fi as well. So just throwing that out there. Anywho, let's continue on this. So we need to find a crystal here. Helencroft, I think, is recommending... Oh, you know what, Helencroft? I could make donate. Well, we have support, Helencroft. We have I think this. There we go, yeah. Should I link that to the Tech Tangents page? I probably should, huh? I should also close Steam. Oh, you were recommending one that has a lot of parts. That makes sense. Because we don't want it to disappear before I order the boards. So, you know, the one with, well, let's go first off, in stock. How about that? That's, oh, what? They just sold out all their crystals, darn. That works. In stock. Apply. Okay. Oh, Digital Ice Age, it is probably coffee. It's just, if I say coffee out loud, you're not going to immediately think of that service. If I say Ko-Fi out loud, you might think, oh, that's a weird way of pronouncing that service. So, clear cookies. Control F5. That's the best I can easily do here on stream. In stock. Apply. Let's do this. Crystals. Let's just in stock. Apply. Because I bet I have, yeah, some tracking nonsense going on up there. Apply, and then package is 49 HC49 some or another. Where is it? HC49U. There we go. Come on, gimme. Oh, I accidentally clicked something else. Hold on. Not from that manufacturer. In that package. 9 and... You gonna do? Oh, it updated. Okay. So here are the 9 that we can pick from. Let's sort by quantity available. That was wrong. All right, so 4,000 at 75 cents. The fewer caps they have, the cheaper they become. Weird. So that's 4,000, and then we got 1,000. Well, I mean, I guess it makes sense that they have 1,000 flat, that they probably just bought a reel of them, and then no one's ordered them. So, not for new designs. I don't like that. So we're probably going to go with this one. So there's our cap. Woo, it's a cap, yay. I wonder how much space is wasted in there. It's probably like a little tiny baby cap down there, but then they have the rest of this because that's what people want. It's what I want, so, you know, but... See, we have an old design. Yes, exactly. Parts distributors' websites being terrible. Yeah. Let's see. So, data sheet. Here's where this gets interesting. All right. So, we need to pick the load capacitance. Oh my gosh, this is awful. This is MPO42, Control F, paste, search. Why are there... They're all 20 PF. Okay, so they're 20 PF. All right. Not a series 1 in the cap column. What do you mean not a series 1? Series 1. I do not know what you mean. It looks like it's 20. You can't see squat. For a 4042, it looks like it's 20 picofarad. Is that reasonable? Is that what we're looking at? On DigiKey, there is a column for the load cap. Okay, that. Well, I don't always trust this. I like to verify it when looking at the data sheet. So, oh, some say series. You don't want that. Oh, okay. Interesting. Oh, okay. Well, it definitely seems like we're going that one then, because we have to get down to the 99 stock to skip that. And the 999 stock. We're probably gonna go with this one. I think we're good. So 20 picofarad. Okay. So now what we have to do is regret closing the Adafruit page. All right. Now we have to do some math. But Gemand already banned the Python calculator, and I really like Python calculator specifically for this kind of math where we have variables that we're filling in and then executing a formula with. I would make this a function where you just input 3 values and then it would have the output that it would spit out, but now I can't. So we're gonna have to do calculator math. This is our first time doing vintage calculator math, and it's here where I can't easily show it to you. Refund the band? I'm half tempted to, but this is literally, this is the first time we've done this. So I feel kind of bad, like, that it's the first time that we've had to do calculations here. So, like, on stream. So let's just do this. So, all right. Calculadora doing Los math. 0 enter. Okay. Raw. Oh, I don't want to be on the user keyboard. That's gonna really mess me up. Spreadsheet time. I do it in Python because, yeah, first actual use of the Python band. It is. This is that. That's part of why I don't want to, like, undo it, because, like, they earned it. This is the real time to do it. So, okay. I'm half tempted to try and write a program on this, but I don't want that to be the rest of the stream. Oh my gosh, we only have 30 minutes? We've gotten through none of this. What? Set up proper net classes for trace lengths. Fix ground connection ISA slot. I've kind of fixed that. Probably as much as I'm going to at this point. All traces connected passes need adjustment. That does still need tweaked. Adjust silk screen. Mostly done. Ref deses being weird shapes is all that's left. Possible hide passive ref deses onto the parts. Oh, I just hid them. Oops. Okay. I did remove them entirely though. Final stream tomorrow. No, final stream is today. I'm sending the email today. I don't care. We're not dragging this out another day. We're done with this on stream until I have something in my hand that we can poke and prod. Finish schematic refactor. No. Create more accurate silkscreen match original. So on that, let me bring up the PCB thing again here. I kind of figured out how they're doing it, and have it slightly accurate. I mean, their font's different, so I can't really do much about that. But so like the 4, it doesn't go up on the back. There's that. But if you just change the aspect ratio of the text, it looks really close. So I'm actually kind of happy with that. I have not done it on any of the reference designators yet. So if we look at that one, we can see that does not look quite the same as, say, this one. But if I just get rid of the U, which I can do, and then squish it in, that'll be good enough. So I'll just do that off stream, then make it the same size, because, well, maybe, unless we get this done, like, super easy. Can make board pretty while you wait for answers? Exactly, yes. So we get this done, and then, so that, recreate part number sticker, I do want to do that. I may have to do this in KiCad, actually, because it seems like, let me just bring this up. I just want to explain this really quick. I am going to waste time on this, probably. I want to recreate this label. This is on the inside of the bracket here. I want to recreate this because it has the part number and other stuff. I think that would be fun. I tried to run this through a font identification service. Couldn't find a good font match. It's just kind of too low resolution. It's like 3 pixels for some of this stuff. So, but I would like to recreate that label. So I will probably do that. It looks like the exact same font they're using on their schematic software. So I might just be able to make like a PDF with schematic information and some lines on the silk screen, and then just print the PDF. Well, actually, maybe literally print the PDF. Actually, that could work. To make this, so I'll probably do that. It is made in Holland. Well, it's Philips, so yeah. Update it to say made on Twitch. No, I'm not changing any of this. It is, the intention is for it to look as stock as possible. Oh, I didn't finish the thought though, on the PCB, with the date code. So on this, there is a date code right here that has changed. So this was 1985 when this would have first been made. This is from the PCB manufacturer. I want to make this say 2208. I do want to do that. So I will do that. That's a time waste, but I'm going to change that. So C8 needs 100 nanowatt. Let me find C8. Where is that? Was it there like one that I put near actual logic deal? Well, Digital Ice Age, if you think you could identify it, it's in the GitHub repository, that image. So you can try and find it there. You just had it in view. Cool. There's probably a way of searching. Control F. Oh, there's a way of searching. C8. Boom. There it is. Edit. 100 and F. There we go. Alrighty. So there's that. Good catch, Shancroft, thank you. Anyway, so we'll make this on the PCB before we're done, but I'm not gonna do any of the other markings, because the PCB manufacturer, they're gonna add their own markings to this thing as they produce it. And then some of these actually might be related to the revision, and I don't understand the revisions, and I don't want to put incorrect information on there. So we're gonna omit everything that I don't understand. So. Ban all keyboard button? What? No, we will not be banning keyboard stuff. Although I will say, I didn't really mention this. This is the keyboard. You can watch a video about me kind of half making this keyboard. That was released today. It's nice. It was stupidly overpriced though. But I do like it. But it has some faults. So yeah. Most exotic components may be difficult to source. Create final BOM parts. Yeah, that's an after all this. Card edge bracket may not mount to PCB. You can choose the location of markings for free or even disable for money. Yeah, but the thing is again, I don't understand what these mean for the card, and I don't want to put the wrong markings on there if it means it's a specific revision. So I'm not going to do that. So yeah, I guess it's just passive values, and then what was the other thing? So refdes, ground to the ISA slot, traces. Yeah, okay. put PCB house marking under DB15. Can I, if I can pick it to go there, absolutely, that'd be awesome. I don't know if I can pick it, but maybe I'll just have it in notes, like bevel the edge and then put your marking there. Maybe. I still plan on having a clone by Shelby / Tech Tangents and crowd marking under the UART. That's going to be the one derivation, so we'll do that. I swear there was another thing. Resistor values, decoupling caps, X-style. That's done. Traces, so okay. I guess we just need to do the cap. Let's do the cap. Gross. Read FAQ on your board house of choice, set up marking location. Okay, I'll look in that. Yeah, if I use the name Shelby Tangents, David, that might have saved me some problems with something else. Alright, let's see if we can figure this out. Okay, load values. I guess it's just plus. Ow! Oh, this is super easy to calculate. I don't know why I'm making a big deal out of this. So, as long as the stack goes slightly higher, yeah, this is not going to be hard. Yeah, I think this has a 4 register stack, so we can do this. So it's 20 PF. Okay. So it's 400. Okay, yeah, 400 divided by 40. So, what? Yeah, because 20, enter 20 times 400. All right. And then 20, enter 20 plus, and then divided by, it's 10. Okay. And then plus C-stray. So they recommend C-stray be 2 to 5 picofarad. So basically, we're just 12 to 15 picofarads for the caps. So yada yada equals 8. But that's lower. What? 4 for the strange layout. Yeah, by the way, I'm so glad you got NDI working. Yeah, me too. It's awesome. Were you here for the Steam Deck part, David? Because I got it working on there too, so I can just like hold up the Steam Deck and show capture. I'll have to try with a game at some point, but we don't really do games here, so it's kind of moot. You were not? I'll do it again before we end. I'll do it at the end as I walk over and end the stream. How about that? Although I will have to turn it on. So, okay, I want to match their math here. Hold on. So, 16 times 16. Oh, hold on. No, I'm an idiot. 0, 0, 0, 0, 0, 0, 0, 0. Okay. Enter. Okay. 16, enter. 16, multiply. Okay. 256. Makes sense. All right. And then we're going to do 16, enter. 16 plus. And then divide. Equals 288. That's wrong. I pressed the wrong button. 0, enter, a bunch of zeros. Okay. 16, enter, 16, multiply. 16, enter, 16 plus. And then the divide key this time. 8. Okay, so that lines up. So 10 for our 20s. So, Helencroft, you're saying plus 4 for the strange layout. Okay. So here's what I say, all right? So we say we're going to get this exact cap. So, all right, let's just grab this, edit. How about this? Let's just link the data sheet. Data sheet, boom, all right. Add value, part number, and then we're going to put this in there, and then I'm also going to add load capacitance equals 20 PF. All right, Get or find new drive for the NAS yet? Oh, Tyler, who did you not watch the mail video? Stuff changed. Yeah, we can make the part number visible. Show. Boom. All right. So you did not Tyler Hoot. That's a big old stack of server stuff. There are 39 256 gigabyte SSDs, and then two, I want to say MSA 7D SSD, or no, 2.5 inch drive enclosures. So the SSDs are going to go in there. I just need 11 256 gig SSDs, and they can go all SSD. So yeah, plans changed. So I'm gonna have like 12.6 terabytes of SSD raw. So I'm gonna make it like 10 terabytes of SSD storage here, which is gonna be insane. So I only need like 5 or 6 terabytes for the stuff that I want to store here. So the rest of it can be incoming to what was on top is a 44 tape storage box library with 2 LTO drives, and it's going to be probably LTO 4 and LTO 5. So yeah, any RAID redundancy, yeah, it's going to be parity of like about 20%. That's about what I'm going to shoot for. So that's why it'll go from like 12 to 10 terabytes. But yeah, there's going to be 50 SSDs there by the time I'm done. I will definitely have some parity going on. Anyway, could use ZFS. I will use BTRFS. Because I like that, and then if for some dumb reason I ever install Windows Server, I can still access it from there. Oh, actually, I wouldn't be surprised if they somehow blacklist that. I don't know. I bet it would still work, but Windows Server gets weird. Probably just install like regular Windows. Anyway, so these values get weird. So Hunkrof's recommending 4 picofarad. So we could say this is 14 PF, all right? So not 14F, that would be a really big clock cap. So we're gonna say it's that, right? But here's what's gonna happen. I'm going to order 12s, 14s, and 16s. That way we can swap them out if we need to. So that's going to be, I'm gonna make a note here in this 14 PF, and I'm gonna copy this in. You don't need to swap caps? What do you mean? Well, I don't know what the C-stray value actually is going to work out to, so that's why I'm saying I will have a range of capacitors. I will order them, just calculate it, will be fine. But I don't know what C-stray is. I can't calculate C-stray. So that's what I'm saying is order extra capacitors for a higher C-stray and a lower C-stray, and then what we think it probably is. It's not critical? Oh, well, it's also going to cost me like, what, 20 cents? Let's see. 16 PF 1206. $0.41 in stock. Packaging, cut tape, apply. There's one. And they're 40. Okay, so it'd be 28 cents for 10, so it'd be $2, $3. So it'd be $12 to overbuy. Ooh, that's rough. Who wants 1206 these days? Yeah, I guess that's fair. Hadn't considered that. So that's that size. So let's say 14. All right. None. Uh-oh. Let's go back to the search and just adjust the capacitance. That could be bad. We might have to order a different value just to get one. Ceramic, I guess. $14. Ouch. I don't think I got it in that size. Just rip 2 crystal caps off a dead board, you'll be fine. Like this one? Actually, why don't I measure these? That would make sense, right? This is probably the same frequency cap. Actually, hold on. Is there other stuff I can measure to answer some questions? I don't really want to kill this card because I do want to get an internal LMSI drive. Well, I guess this, well, it has an internal connector. I would like to get an internal one that this would work with. There's a really cool, there's actually a couple cool caddy ones first. Desolder first and let them cool. Yeah, I won't be doing that today, but that's an option. I don't, oh, do I own anything that can measure this low? I own the ESR meter. That could probably do it. How do you do it? Yeah, I have an ESR meter. That's how I would measure these. I don't know if it's rated to this low. Was it DUR 2000? ESR meter. That. I don't think I paid $239 for that sucker. Holy moly. I'm not clicking that because it will show the address I went to. Wow. Okay, what's the low value? Actually, let's just search this. So, I don't know, this will go down to like pico, like 12 picofarads. That seems a little hard. Like, the cable's probably going to be more. Minimum 200 picofarad. Okay, that's a no. Only critical cap's the one on the only critical one's the one we have no idea what it is. Cool. Why couldn't they have printed codes on capacitors? Jeez. There's no way I can ask them to measure that cap because they would have to remove it. And they would almost certainly destroy it. Well, I guess it's a 1206. It wouldn't be that hard. But you can't measure it in series. Well, actually, can you measure that one in series? It's not that bad. They're really not that critical. All right. Will it work without them? Don't overthink it. All right. I want to put 12 to 16 PF range. Boom. We're just going to do this. And there we go. Most likely. All right. Not joke. Okay. Well, we'll just get whatever we can find in there. We found 16s. We'll see if we can find 14s. Looking like probably not. Here we go. Sizes. Search filter. No, that's series, not size. Package. 1206. Click. Nope. It says you cannot have. They got them in 0805. I could probably fit that. Why does that look so weird? That can't be 0805. Oh, it wasn't 0508, was it? No, it's 0805. 1206 metric? That would be a little big, wouldn't it? No, it'd be really small. What's the tolerance of these caps anyway? Ceramics I thought were pretty tight. Yeah, 5%. May not to get the best safety margin and stuff like that, but you really don't care about that. All right. Well, we can figure that out. That's not critical. We have a rough idea. That's the range that we're looking at for those caps. So we'll go with that. So that ticks pick passives, I think. Determine passive values. That's all of them except for the one. But we've kind of got that done. So 3 done. So found 10 PF ceramic caps, 47 cents for 10 on DigiKey. 10 PF, yeah. Yeah, 1206, that's the thing. Yeah, it's probably the really weird size is going to kill me on the price. So, yeah, we have all of the passives then. So we can definitely move on. Let's work on, how long do we have? Oh, we really have no time. I should end it. I will do a little bit more cleanup on the actual PCB, all right? Because like I mentioned, I did not cleanly route any of the traces going into the SMD parts. I just kind of connected them to make the nets happy. Like this over here, that's horrible. That's so bad. You cannot have this. That is no. So I need to go through and I need to clean all those up. I'm gonna try and do it, maybe order from Mauser. I can look at both, yeah. I'm gonna put all of the manufacturer part numbers on the, I'm probably gonna do the Caps Wiki thing. I'm probably gonna have a set of parts picked for DigiKey and for Mauser and put them in the table at the bottom of the README on the GitHub repo. That way we have 2 options for everything, just in case one like sells out or something. So yeah, I'll pick both and then I'll see what makes most sense to buy. I'm gonna way overbuy parts, like a lot. Like I might have enough parts to build 10 of them. I don't know, we'll see. It depends on how expensive some of the chips are. But I'm willing to spend like $50, $80 on parts on this, just to make sure that I have them. So order UART from AliExpress. Oh, am I really gonna have to? I thought I could get them somewhere normal. 81.52, I think that's what it is. I have no idea what that would count as. Let's try 8152A, because that's technically what it is. Clock timing, kind of. Logic, that's probably more what it is. That's not it. All right, well, I will have to look around for that. That's gonna be fun. But yeah, so maybe that'll determine how many I buy. Because they're like $5 each. Probably gonna buy like 3 of them. So yeah, I want, and no matter what, I'm gonna order enough parts to build 3 boards. Because I want to be able to, I'm gonna order sockets too. The first board we build, we're gonna socket. That way I can lift pins off super easily if we need to try rerouting stuff. Oh, hello. So the first one's gonna be completely socketed. Second one, marketplace product. All right. So they have Woo, yeah, maybe AliExpress. $16 each. Ouch. So yeah. Okay. Well, I will look around. Yeah. But yeah, building minimum of 3, because I want one that is socketed, one that will be hard soldered, and then I want to have enough parts if I hard solder it and then find out there's an issue to spin another board and get that, and then build a functional one out of the last set without having to order more parts. So at minimum, 3 parts worth. And then there's a possibility that there's some blown buffered chips in the CM-100 or something, because I sent power into it. So that's an option too. Yay! But all right, let's go over to there and take a look at some stuff while I fire up the Steam Deck so I can show David, who's hopefully here right now, OBS NDI running. Topic for tomorrow? No idea. I have no idea what tomorrow's topic is going to be. Oh, Steam Deck. I don't know if I want to do like a whole Steam Deck thing. I don't think so. I'm not really like a gaming folk. That's the wrong one. Bye. No, I'm just kidding. When I click the scenes button, it does that instead of the correct stuff. Oh no, it definitely won't be that, Dogface. Like I said, I need to do a lot of research on that so I can fully understand it. I don't think, well, I do need to do some other stuff, like do the disk images and get it put together pretty, like, I don't know. Take the drive apart to check the drivers in there. Oh, I'm so scared. I kind of don't want to. We could do something servery. Actually, that would be beneficial to do something servery just so we can make some progress on that. So maybe. Let's see. Switch to desktop. Yeah, what do I have? Nope, I know what we're doing. I know exactly what we're doing. It's something none of you know anything about. Oh, wait, no, I talked about it with the, one moment. I talked about it with the shelves video stream. Yoink, yoink. This will be preparation for next week's video, which is going to be about this because I'm going to force myself to do a video about it so that I get started on it. This is a professional label printer, and I have a whole bunch of professional labels to go with it. And I have these, which are paper tags with strings, and I'm going to be printing asset tags to put on items. So tomorrow we'll investigate this so I can begin that process, because I want to start a media wiki page that'll run on techtangents.net to track items that I have, what the conditions are and things like that. Probably where they came from as well, different things. Yeah, print labels for the card. That's exactly what I want to do. Oh, yeah, you're saying, I don't know if the resolution's high enough. We can see, but I was probably going to use just the laser printer I've got that definitely has high enough resolution. Anyway, hopefully David's here. If you are here, David, you should let me know just so I can know that you got to see it. Tools, NDI output, deck, okay. And boom, Steam Deck NDI output. So there it is. Just like straight up Wi-Fi capture. Let me try something here. I'm gonna launch a game. See how this works out. Well, I guess I could have done this without. I just don't want to dox my Steam username. I think I have it set to private, but yeah. So let's see. 64 gig. Yeah. How'd you get a Steam Deck so fast? And which one? Yeah, was 64. Now 1 terabyte. I waited a long time to get this, actually. All right, here we go. A game being played on the Steam Deck wirelessly. And this will be... Oh, that's weird. Please don't be tiny. Why is it tiny? Is OBS doing weird stuff? Ooh, I wonder if it doesn't like running in desktop mode. Wow, that's strange. I know what it is. Oh, no. I know exactly what it is. One moment here. Let's do windowed 1280 by 800. Save changes. Oh, that's almost good. So, fun thing about the Steam Deck here. Change Twitch category to game. I'm not going to actually play this here. So the Steam Deck, the display is just from like a tablet, so it's normally oriented like that, and they have to rotate it to get it to work normally. I've set the desktop orientation. Oh, wait, no. I didn't have to set it. For their Arch install, it works like that. Hope you left the cooling pad for the IC. Yeah, I didn't change anything like that. So, but what's going on here is that the aspect ratio of this thing is weird. Why do I only have 2 resolution options? I got 600 by 800 and 1280 by 800 and 1280 by 800. Oh, perfect! Haha! Okay, there we go. All right, continue. Yada yada. All right, let's run a game. Same as my GPT win. Yes, yeah, it's really annoying. All right, let's just go somewhere. I've already got a thing done with. Skip. And yeah, so I want to show you just like high-end streaming wirelessly, because this is weird. Yep, destroy. Oh yeah, Stefan. Yep, destroy all humans, which is excellent. But there we go. Streaming from the Steam Deck wirelessly while playing it. I can turn up the brightness so you can actually see what's going on here. No, I can't. Not easily. Because this doesn't have the menu running because I launched it from desktop mode. So any details on how this is set up? This is NDI. That's the protocol. So it is going from... Oh, I can just do this. Here you go. Now you can see it. Yeah. So it's NDI is the protocol going from one OBS instance to the other. So NDI is kind of awesome. This is like really... Wow, that's loud. Really impressive.
They see me rolling. They hating.
End of line.
But yeah, this actually works shockingly well. This is like not a slouch of a game to run either, so this is kind of cool. I have turned the graphics down just a little bit so that it runs better, but because the display is only 720p basically, you can't really tell. So yeah, it's nice. I like it overall. So but that is it. I did see David commenting, so I'm guessing you missed that. Oh well. But yeah, that's wireless Steam Deck NDI. Really impressive. And that is it for today's stream, I think. So, PCB, done, essentially. Just minor cleanup stuff. At this point, I'm just shutting this down so I can put it in the bag and take it home. So yeah, I will be getting the board files sent off to Roland, who sent me the original images, and I will have them check some things. I'm not sure how they are going to want to do that, so I might have to communicate back and forth with them a little bit, so this may not be like instantly done, just letting you know. And the checklist, yes. Yeah, the checklist of different things that I want them to take a look at. The capacitors, maybe. Don't know if we'll actually get values on those, because they're probably picofarad range, and they're fragile, so we'll see. We may have to guess on those, which will be very much not fun. And then there are the two traces, one going from the response pin of the internal connector to pin like 25 or something for our, is that RxD or is that, yeah, I think that's RxD. Anyway, yeah, send the repo. Maybe they also use KiCad. Yeah, that's what I'm going to do, Helen Croft. I'm going to send them pretty much everything to try and make it as easy as possible. But I'm going to try and not overwhelm them. I just want them mostly to check the two traces and then the two capacitors if possible. That way, it's like, I don't want it to be like, oh, here's your whole afternoon of things to check for me. I just want it to be like something they can do in an hour. You know, not try and monopolize a bunch of their time. If they want to check the other stuff, it would be really helpful, but that's how I'm going to phrase it, is like, these are the really critical things. If you have time to check everything, it would be really nice to just know, but I think we're pretty good on those, so that's kind of how I'm going to phrase it. Who, the company? Do you mean for the PCB manufacturing? Undecided. I don't have one that I go for, so yeah. But that is it for now. I'm so happy to be pretty much done with this PCB. It's taken way too long to get this done. I honestly feel like I've just lost perspective on where I was at with all of my other projects, because this just came along and demolished my plans. So yeah, I'm looking forward to being back to some other things. Something that I wouldn't mind doing, but there's no way we're gonna do. It would be just kind of nice to do. Can you work, computer? There we go. So back here, in the video that I just did on the keyboard, I took a look at some typewriters. Well, I had them sitting next to it. What you didn't see is I actually filmed probably a half an hour's worth, maybe 40 minutes worth, of me trying to fix the typewriters. And on both of them, I fixed a problem, and then discovered each one of them had a different end problem, like not gonna fix. So yeah, and it's kind of the same on both. The tan one has, I think, something like fell in it, maybe, because it's binding in a very tight fashion. The blue one, though, somebody oiled it with like the completely wrong kind of oil, and it has congealed and solidified inside of the mechanism, and a bunch of stuff just straight up can't move anymore. So I have no idea how I can fix that blue one without like a ton of new equipment and effort and time and learning. So it's just blah. So yeah, I'm really disappointed about the blue one too, because it's a kind of rare model. It's not a full-size industrial one, and it's not a personal size. It's a mid-size Selectric one. I don't think they made that size for 2s and 3s, and that's the only one generation that I've ever seen. So yeah, heat gun. No, Kender, the typewriters, we're talking like the whole typewriter, the entire thing. And it's like, if you've never seen inside a typewriter, I would go pick it up and bring it over here, but it's just covered in oil constantly, like the whole thing. You know what, we can do this. How about this? Boom, boom. Typewriter. This is what I would have to clean. All of that. It's a real big, complicated nightmare thing with tons of little metal bits inside of there. All of that has to be cleaned, because the whole thing, it's like they took the platinum so they didn't get oil on the rubber and then just hosed it down. Like there's even oil like gooed up on this, and there should never have been oil on that. So it's really bad. So this thing is, yeah, gonna take a tremendous amount of effort to get that going again, unfortunately. Don't trip over stuff. That was the top of the typewriter. It's kind of nice having that camera in a central position. So, yeah. Brake cleaner, hold on. There's a chemical for every problem soaking alcohol to loosen up the wrong grease. I'd need like 3 gallons of alcohol. That's the thing. So, but also, would that solve the solidified stuff too? Yeah. Crud cutter, you can degrease engines. Yeah, but again, we're talking it's through everything, the whole thing. So again, it will have to be submerged into it. Like we're talking beginning of A New Hope, C-3PO being put into the oil bath. That's what we're talking about here. So I don't know. Anyway, that's a thing. I don't know. Maybe I'll figure something out for that someday. But right now, I'm just I'm gonna just be disappointed about it. So soaking for months in alcohol. Yeah. I mean, what would that do to the metal? Is that acceptable? Alcohol's an oxidizer. Yeah, anyway, that is it for now. I do need to end this so I can finish up the little things on the PCB before I send it out. So I appreciate y'all being here. Those of you who've been helping me out with the PCB and the schematic and all that stuff, I extremely appreciate it. Like seriously, you've helped make this possible, not just like pointed me in the right direction. I'm not sure if I could have done it without you, so I really appreciate it. Yeah, so I'm just putting that out there. So let's see, it will oxidize it. Yeah, that's what I thought. So brake cleaner might not be a bad idea. 3 gallons of brake cleaner would be so expensive. Yeah, anyway, let's go ahead and run the outro here. It selected the outro, didn't switch to it. Boom, there we go. All right, credits under the chips. I'm gonna try and do that, actually. I am gonna try and do that. Yeah, thank you all for being here. Thank you for putting up with this series of extremely boring streams. Like, I know this is not that fun to watch. So y'all hanging out here with me as I work through this, which is a pretty important thing. Like, how many opportunities do you have to get the first ever CD drive working? I mean, there's a very significant reason that I'm trying to get this done, and it is this. I'm just never going to be able to find the card. They're too rare. So getting to this point is really important to me, and I'm glad that there was a way to do it. I really feel confident that we're going to get the card working. I don't know that the first revision is going to be perfect, because that was hard to do, took a long time, many more hours than I want to try and count. Whatever you've seen me stream, it's probably double that because I've worked on it a lot at home. Some days I would come home and there would be way more time during that day than I would work on it if I streamed working on it. So yeah. Anyway, I appreciate y'all being here. If you enjoyed this stream, you might want to go subscribe to the second YouTube channel I have where the VODs for these all get uploaded. And if you want to catch it live, you can find me on Twitch. If you want to help support the channel, there's a page on techtangents.net that links to all of it. That's probably the better way to do that, huh? Oh well. But that is it for now, and I will see you next time. Apja, thank you for the Prime sub. I'll see you next time.